All right. Okay, we start now. So the other day we did the first part of redox reaction where we learned about oxidation and reduction in terms of oxygen and hydrogen. Remember, if you gain oxygen, all right, we call it oxidation. You lose oxygen, it is reduction. Okay. So now and then for hydrogen, it's just opposite. If you lose hydrogen, it's oxidation. You gain hydrogen, it's reduction. Okay. So, and I gave you all the examples. So today we go to another part where we look at what is known as transfer of electrons. This is a more popular part for your SPM. More of the questions will be set on this transfer of electrons. So we look at. So I put here. We look at other characteristic of redox reaction. So you look at A. You note it down first. It is redox reaction can be a transfer of electrons. Write that down. Continue the word, the transfer of electrons. Either, when I say transfer means, it's either losing of electrons, loss, L-O-S-S, kehilangan electron, or gain of electrons. Right? Okay? And then we're also going to look at a change in either an increase or a decrease, write that down first, in the oxidation number. So what is oxidation number? I'll show you afterwards. So two things we're going to learn today. One involving electrons. Somebody will lose electrons, somebody will gain electrons. Okay. Another one is change in oxidation number or oxidation state. What is oxidation number, oxidation state? Afterwards we see. Okay, we look at this one first. This is an oil rig, Okay, we are not learning geography, or neither are we learning about minerals and all that. Okay, but this is an oil rig. Can you see that? This picture here. It's a very big place, It's in the sea there, see? You see that? All right, and they even have a helipad for the helicopter to land. Most of the staff will all come to work by helicopter. They won't come by boat or it's quite far in the sea. Okay, the helicopter will come and bring the stuff. And they work roughly about, in a month, I think they work about 3 weeks, and then 1 week they're off, And then they rotate. Okay, so they do drilling, This is a few examples of oil rigs, and they do drilling. They'll drill into the seabed to get the natural gas or petroleum and all that. We have a few oil rigs in Malaysia. If you go to Terengganu, you can see. You go to Sarawak, you can see. Okay, these two places. Miri and all got a lot of oil rigs the other side there. Okay, all right. Why am I doing this? Okay, it's nothing related. Okay, why I'm using this word oil rig? We look at this one first. The word oil means, you see, I want you to write this word here. All right. Oil. What does oil? I know oil is oil. Okay. The O comes for oxidation. Write down first. Oxidation, short form. Oxidation. L means loss. You lose electron. That's why you remember that. Oxidation means you lose electron. That's the easiest way to remember. You're not learning about oil. We're learning about oxidation. But I just use a short form to remember. Oxidation is loss. All right? Here you write down loss. You lose electrons. What? And then I space it out. Rig means, all right? Reduction. Okay, you put the word reduction. R-E-D. Okay, rig here. Reduction is, right, in detail, reduction is gain. Reduction is what? Gain of electrons. Oxidation, you lose electrons. So you have to remember that. Okay. Those days when I learned chemistry, my teacher just forced. Okay, oxidation, you lose electrons. Okay. She never told us anything about oil rig and all that. So difficult to understand. Okay, Right. So we have to take a short form to remember oxidation and reduction. Okay. Any questions? I think it should be okay, All right. Then we go. Okay. So I just told you here, oxidation is a process of losing electron. Can you please highlight that one? And reduction is a process of gaining electron. Either you lose or you release. They use these two words. Or either you gain or receive. Sometimes you use the word receive electron. Sometimes you say you gain electron. These are two words. But what are we losing and gaining? Electrons. Nothing to do with oxygen, nothing to do with hydrogen anymore. You understand? It's the next part of redox. Okay, so far, okay, oil rig. That's why you remember from your oil rig. Okay, let's go straight to an example now, where we use this oil rig now. Okay, ready? Okay, so you see here, look at the equation there. Right. You don't even have to worry about the state. I remove the states. Okay, the physical state. You, actually, this one, what you take sodium, you burn it in chlorine gas, you understand? Right? And you get sodium chloride. We have learned this in our, when we studied group 1, Group 1 metal burn in chlorine gas when you studied a periodic table, form 4, to form a salt. Okay, and I just balance it. Can you see that? All right. In fact, I don't even need to balance now. Just leave it like that. So you can see clearly. Okay, so you see from here, there's no oxygen, no hydrogen. But how you know this is redox? This is a redox. How to know? You understand? Earlier I gave you oxygen, hydrogen, losing oxygen, gaining of oxygen, losing hydrogen, all that's enough. But now it's another step really, Okay, so how to know? Okay, you look at this one first. I want you to do something for me. You use this one. Okay, you take a ruler. No, sorry, you take a pen. You draw an arrow going like this first. Okay, can you do that first? Na going to Na here. And then I use another color, blue in color, Cl2 going to, okay, can you do that now, please? Yeah, I also did like this for you, isn't it, for oxidation reduction. Okay, so you follow the arrow here. So here I put Na becoming Na plus. Okay, why is this Na plus? Because you must remember, Alicia, can you try? What type of compound is this? Alicia Ong. What type of compound is sodium chloride?
An ionic compound.
Ionic compound, very good. If it's an ionic compound, what type of particles is found inside it? Alicia, continue.
Ions.
Ion, yeah, well done. So you can see sodium chloride. This is just sodium, metal element. Okay, this is a gas molecule. This is atom, but here it contains ions. Means that's why you see I put Na becomes Na plus because there's sodium ions. Can you see Na here becoming Na plus because this contains ions. Na plus Cl minus. And the same thing here also. This is chlorine gas molecule containing chloride ion, Cl minus. The chloride ion comes from. So this is the change we are looking at now. This is the one we are looking at, and this is the one we're looking at. And how to know whether it is oxidation or reduction. Are you following me? Okay, so I'm going to teach you a very simple way. So first, what I write here, because this is sodium, but what is the element? What type? I'm here, I put AMI. What is AMI? Elisa Lee, what is AMI? Form 4, I taught you. What is AMI?
What's AMI?
What is AMI? Form 4, I told you. Satish, tell me, Satish, what is AMI?
Atom, molecules.
Aku makan itik, remember? No? Yeah, now you remember. Alright. AMI means aku makan itik. What is aku? You're not eating itik, alright? A means aku means atoms. M means molecules, or I means ions. So here I put AMI because you have to explain in terms of the particles. Type of particle is AMI. Remember we learned in Form 4, Alright? Aku makan itik. What I mean is I taught the Pascal class. Okay, those who are with Pon Bisma, I don't know what she taught you, Okay, but this is how we remember. Type of particles will be atoms, molecules. Okay, so you must use the particles here. Okay, so you see here, I say sodium atom because this is element. Contains atoms. Still people coming waiting room. Okay, all right. Sodium atom. Can you highlight? Take a highlighter and highlight. Sodium atom. This one, is converted to Na plus is sodium ion. So we are using only the particles. Okay. All right. Here you can see chlorine is Cl2. So chlorine molecule is converted. You can see this one, isn't it? Is converted to this Cl minus chloride ion. So you're using the particles now. For this oil rig, you must use particles to explain. Okay. Then the next thing. Is it okay? So this is settled. This is also settled. Okay. Now we go for this one. Why I say there's an increase in charge. Okay, let's check it. What is a charge? Nothing means zero. The charge is zero. All right. And then what is Na plus? The charge is +1. The charge follows the charge on the ion. So now you look at maths. We do maths, isn't it? If this is 0 and this is +1 on this side, isn't it? Or I just put 1. This one I padam. Okay. Sorry about that. You see? You're going from 0 to plus 1. Can you see now? All right. So 0 to plus 1, you're going to the right. Is that correct? 0 to plus 1. So whenever the arrow goes to the right, it is oxidation. Means increase in charge. From 0 to plus 1. That's why I say increase in charge. Can you see that? Okay. So the moment you see it's going to the right, the arrow moves to the right here, 0 to plus 1. So the process here is oxidation. Write that down. What process it is? Oxidation. Write in detail now. I just put short form here, but you complete. What's the name of this process or type of reaction? Oxidation. Increase in charge. I never learned all this last time, you know. See? Okay. Simply, we were those days we were forced to memorize. Now I make it very easy for you. I use the word oil rig. I use the word increase in charge. Okay, Now we go to this side. Why did I use the word decrease in charge? Tengok sini. All right. What is the charge here? Cl2. Okay, you see, it's nothing there. No charge in it. It's just a molecule. All right. So put 0. Arrow. Okay. Now what is the charge here? -1. Correct or not? Okay. So now you learn in maths. 0 here and then -1 is here. Correct? You're going to the left. Although the arrow showing the right, isn't it? But you see the charge. 0 to -1. You're going, as long as the arrow goes to the left, 0 to -1 or 0, -2, all of that, that is reduction. Okay, so reduction is a decrease in charge. Can you see that? So write the word here, reduction process. So this is the first thing you have to know. Oxidation process, reduction process. Any questions so far? You have to understand this, extremely important. Okay, so we have looked at the particles and then we look at the whether increase or decrease. One increase in charge, the other one must be decrease in charge. Okay, and then what's the name of the process? Oxidation, right in detail, reduction. How you know reduction? The arrow will go to the left. Oxidation, the arrow will go to the right. Any questions so far? You have to understand this, All right, very clear. Can I continue? Okay, so now one more last thing. We write a half equation. Okay, what is this one? You have learned before when you studied electrolysis. You did half equation at the anode, half equation at the cathode. Remember? Okay, we will refresh it now. Okay, all right, very simple. Okay, so what we're going to do is, again, I use my drawing tool. Okay, so you know this is 0 to +1. Correct or not? Going to 0 to +1. Okay, 0 to +1 is oxidation. Correct or not? 0 to +1 is oxidation. And remember, oxidation is oil. You may have that in mind. Oil means oxidation, you lose electrons. So actually the equation is like this. I do it on top here. Na, all right, will lose 1 electron to become Na+, because oxidation is loss of electrons. Can you see that? If it's 1 plus here, you will lose 1 electron. But you cannot write it like this. Half equation, you cannot write this way. Because this is oxidation. All right, you lose electrons. Okay, so the -E goes to the right. So here the minus, so Na, arrow, Na plus E. So this is what I want. This is my half equation. You want, you can write it all of this below, but this is what I want. This is my half equation. Why we lose 1 electron? Because there's 1 plus there. Okay, get it? That's a half equation, all right, for oxidation. So this process is oxidation. How you know oxidation? You lose electrons. But the -E, you cannot put -E, you must bring it to the right. Remember? Okay. Then we go for this. Okay, this one is a bit tricky, Okay. Remember, we have Cl2 becoming chloride ion. There's no Cl2 minus ion, just Cl minus ion. It's not balanced, You check and see how many chlorine here. Here, see Na and Na. The atoms are balanced, then we just balance the charge. Okay, here you see how many. There's 2 chlorine. Here only 1 chlorine, So you must balance it, put a 2 first. Write that down. We balance. Okay, 2 chlorine, 2 chlorine. Okay, settle, Okay, then this is 0 here, correct? Okay, now what is the total charge? This is -1. -1 times 2 is -2. Is that correct? So 0 to -2. Check and see first. Are we going right or left? Saying 0 to -2, right or left?
Left.
Left, isn't it? Very good. So left means reduction. Reduction is gain. R-I-G. Have that in mind. I told you. Gain. Gain means you receive. So when you receive, you must put the electron to this side. Receive means you must put a plus sign. Donate means you must put minus sign. Okay. So if it's 2 and 2, so you must, to balance the charge, you must put 2e. Can you see now? If it's 2 minus, so you put 2e. That's a shortcut lah. So this is your half equation. You see, your half equation can only put plus e. Either you put a plus e on the left side or plus e on the right side. That's a half equation. Okay, get it? Some of you wondering why I put 2e there. Okay, I'll show you. I will padam this. Okay, I'll show you. I guide you. Okay, why I put 2e? Okay, you see, you check and see this for this first. Okay, this is 0, isn't it? No charge here, 0. Okay, plus. Okay, 2, you put 2 there. Okay, 1 electron has got a charge of negative 1. So 2 electron will be minus 2. Minus 1 here, sorry. Okay, can you see, All right. And then here, what's the total charge? Minus 1 times 2 is negative 2. So when you balance the charge, when you write the electrons, the left side and right side charge must be the same. Let's check. This is 0 here. Plus minus becomes negative 2. Correct? And here also my negative 2. So you see the left side charge is negative 2, right side charge negative. So you balance the charges. So I put 2e there. Understand? I put 1e here so that the left side and the right side charge will be the same. The total charge. Okay, get it? Alright. Oh, finally, Tam Jashan has entered. Get it? Tam Jashan has entered here already. Okay, please note it down.
Okay.
Because Shinmi is keeping tabs, She told me to inform her. All right. So she has to inform his parents. Okay, any questions so far? So we're going to do one now. Okay, let's do it now. This idea. Okay, let's try this one. Again, the upper part, I put AMI. Okay, let's try that. Here again, magnesium is, this one you did the empirical formula experiment. Magnesium, you burn it in air. All right, you'll burn with a very bright flame and then it'll form oxide. Okay, the equation is just to balance. Anyway, I just removed the 2 there. Okay, I want you to concentrate so you can see here. Okay, check and see first. Okay, 2. You can see from here, Mg is going to Mg2 plus. Why you can see here? Can you see Mg? This is magnesium oxide. Again, magnesium oxide is ionic compound. There's magnesium ion and oxide ion, O2 minus. So Mg going to Mg2 plus. Oxygen is O2. Okay, going to, actually it's going to O2 minus. Okay, actually it's O2 minus there, but I balance it because it's O2, I put 2O there. Okay. All right. Anyway, you don't worry about that first. Okay, let's go for this one first. Okay, who wants to try? Sean, want to try, Sean? First one, first row. Magnesium atom, what's the word? This is 0, this is plus 2. Correct or not? What process? Oxidation. So what do you put here? Oh, Jaden, try?
Loses electron.
Increase in charge.
No, I know, increase. Here what? It's oxidized, correct?
Sorry.
Loses
Okay,
electron.
magnesium atom is oxidized to form magnesium ion. Because why is oxidation? 0 to plus 2, how you know? Increase in charge. Magnesium atom is oxidized. Okay, to form a magnesium ion. Okay, Here, O2 is oxygen molecule. Okay, 0, you can see here the charge is 0 or the total charge minus 4. From 0 to minus 4, we are going the left. So, continue, Jaden. Oxygen molecule is what?
Reduced.
It's reduced to form an oxide ion. It's reduced to form, okay, the ion of oxygen, you don't say oxygen ion, you say oxide ion. O2 minus. So actually, Mg is forming Mg2 plus, O2 is forming O2 minus. From there, you know already. One is redox, one is oxidation, one reduction. So this is a redox reaction. Okay, we continue now. That's the increase in charge, 0 to 1, plus 2, isn't it? Okay, write that down first. From left to right, correct or not? Here, you can put the original charge first. No need to put minus 4. You can just put the original charge is 0, O2 minus. You can put negative 2 there. Okay, you want to put negative 4? No problem. Okay, we put the original one. Let's say that we remove the 2 first. Okay, its original is O2 minus oxide ions. Okay, we continue. Okay, then we go. Okay, what process is this? Oxidation process. Process is oxidation. Here, you're going from 0 to -4 backwards. So, reduction process. Very simple, huh? Right. Now we go for half equation. Okay, let's try that now first. Okay, half equation, huh? All right, 0 to +2. All right, oxidation. Oxidation is loss of electrons. So the Mg will lose 2 electrons, correct? Because it's balancing of charge 2 plus. So the -2e becomes +2e. All right, 2e. Original one was actually like this. Mg, all right, -2 electrons. One atom of magnesium will lose 2 electrons, become a magnesium ion. But as I told you, all right, because there's 2 plus, you must put 2e there. You understand or not? Okay, you cannot put a -e, you must bring the -e to right. So this one will be +2. So this is your half equation for oxidation. Later we'll do in more detail, huh? All right, there's other half equation coming in. Okay, let's check this one. All right, ready, huh? Okay, original one was oxygen. Okay, magnesium oxide is O2 minus, but it's not balanced. See how many atoms? O2 here, only one O here. I'm not talking about charge, the charge is 0 here. So you balance the number of atoms, you put a 2 there. Can you see? 2O, O2. Can you follow me now? Okay. So now you can check it's 0 to -4. Correct, not 0 to -4. You're going to left. Left is reduction. Reduction is gain. So gain means you must put plus. Plus how many E? So there's 4E here. Can you see 4 -4, so you must put 4E there. So the half equation is O2 plus 4E arrow 2O2 minus. No need write the states or no need, whether gas or no need. So you see this one you lose electron, this one you gain electron. So they want the half equation, they want to know what's the name of the process, and they want to know what is oxidized. What is oxidized to what? You must use AMI. Aku makan it. That's all for this part. Okay, we're going to try now, huh? Okay, so and they say as oxidation, this is reduction taking place same time. This reaction is the redox reaction. Mg plus O2 redox reaction. Okay, all right. You clear? You try it now. This one. Okay, you try this first. This time is okay. It's not balanced. You see, okay. I want you to do something for me now. You do the same thing like what we did study, huh? Okay, Mg, you put an arrow going to Mg2 plus. H plus is, this hydrogen ion is acid, huh? Please note it down. Acids contain, this is the ionic equation. Acids contain hydrogen ion. H plus is forming H2. You do that first. So that's why you can see here, I put Mg becomes Mg2 plus, H plus forming H2. Of course, I'm not balancing. Never mind, don't worry. I just want you to see first. Okay, you try now. Fill up all the blank spaces. The first one is something is oxidized, something is reduced. Okay, Yu Cheng, are you ready, Yu Cheng? Are you there? Yu Cheng?
Yes.
Okay, you try the first one for me.
Converted.
What is AMI?
AMI.
What is AMI?
Atom, molecule, ion.
Well done. Aku makan it. Very good.
Yeah.
Magnesium atom is, the word it must be, what process is it? So it's oxidized, not
Oxidized. Oh, okay.
The word is oxidized. You can see 0 to +2, what increase in charge to form a magnesium ion, Mg2+. We are talking of all the particles only here. Here, hydrogen ion is H plus, is what?
Reduce.
Reduce, You can see this is 0 to, this is +1 here. You can see here, +1 becoming 0. You're going to the left. So it's reduced to form a hydrogen molecule also. Okay. We talk in terms of particles. Okay. Then continue, Yu Cheng. There's an increase in charge from what to what? Okay. What number you put here? Nothing. Nothing means what?
0.
0. Here, what's the charge?
2 plus.
Or we can put +2.
Oh, +2, +2, +2.
Okay, very good. Okay. Here, +1 to what? 0, isn't it?
0.
Charge. Okay, so what process is this, Yijing?
Oxidation.
Oxidation, well done. Huh? Just increase in charge. Here,
Reduction.
reduction. Huh? The charge decrease means the arrow goes to the left. Okay, so can you complete the half equation for me? Mg arrow becomes what?
+2E.
On the right side. This is advanced, this is oxidation. And the 2E goes on, and there's a plus on the right side of the equation, it is oxidation. And here, this is 2H plus 2E on the left side. Okay, right?
Oh.
That becomes H2. Okay, very simple. Okay, this is how we explain the oil rig thing. So this reaction is a redox reaction. There's oxidation and reduction both taking place at the same time. Okay, go next one. Okay, copy first, quickly. Go number 4 now, quickly. Okay, try this now. Okay, so after this, we go straight to oxidation number. Again, you do the same thing. You do the one I taught you to do. Okay, you go like this. Zinc going to Zn2 plus. H plus is going to H2. You do like that. Okay. From there, you identify it. Yongsin, are you there, Yongsin?
Yes.
Okay, you want to try? Okay, I'll give you a few minutes first. You try. This is now your turn. You just try. You make a mistake, you learn. Don't worry. First part again, I told you, you write down here AMI. We use AMI to explain. Atoms, particles to explain. I put 2H plus because I'm balancing it here. Can you see? It's balanced. Okay, you try? First you say zinc atom is what? What's the word?
Oxidize.
It dies, Good. OXIDISED. Okay. And here hydrogen ion actually is H plus, Okay, H plus is plus. Actually it was H plus, original one is H plus, becoming H2. Can you see now? Okay, this is +1 to 0, that's H2, so no charge, 0. The original one is +1 to 0. So we are going to the left. So hydrogen ion is H plus is what? What's the word?
Reduce.
Reduce to form, what is H2 called? Hydrogen 1.
Molecule.
Okay, molecule. You can put bracket there, gas, Good. Okay, first one done. Okay, let's look at the charge. 0 to +2, correct? This one, this is 0, this is +2. So you put here 0 +2, increase in charge. Here, we look at the original one. Okay, you can put +1, H is +1, H plus, +1 to 0. Correct, You're going to left. Okay, continue, Yongsin. Here, what are you going to put for here now? What process?
Oxidation.
Oxidation process. Very good. And the right side?
Reduction.
Reduction. Okay. So now we go for half equation. Want to try this one, Yongsin? Half equation. Oxidation, I told you the +2E must put on the right side. Whatever the plus, what? How many E are you going to put? You're going to put plus how many?
Plus 2E.
2E, to balance the charge. Okay, here, okay, actually it was original one is H plus, but you can see H2 there. Can you see? So I put 2H plus. We balance the atom. Okay, but there's no space here. So you must put plus 2E on this side. So this is reduction, you gain electron. I mean, you just put on top there. Okay, very simple, All right. So this is how we have explained oxidation and reduction. What we learned yet, the previous lesson was oxygen and hydrogen atoms. Somebody losing, somebody gains. Now we are playing just with the charges. Can you see the increase in the charge? And then we use the word, this is called transfer of electrons, Transfer means somebody is releasing electrons, somebody is gaining electrons. That's why I call it transfer of electrons. One you can put here, can you put bracket here? TOE. Transfer of electrons. When you talk of transfer of electrons, we talk of losing electrons and gaining electrons. Okay? All right? We continue. There's a bit more. All right. Now, this one is just a simple calculation, but this is a very important thing. This one comes out in your paper 1, multiple choice, and also it comes out in a paper 2 stack. Sometimes they ask you to calculate. So what is oxidation number? Or another name for oxidation number is oxidation state. I'll give a very simple example. Right, when you studied about transition elements in Form 4, one of the Satish, can you tell me what are the few characteristics of transition elements not shown by other elements? Satish, can you try?
Colored.
They form colored compounds. Okay, that's one.
Compound.
Okay, colored compounds, colored ions. Correct, Okay, Elisa, Ali, continue. Another character of transition elements.
They have different oxidation states.
Okay. So what was oxidation state? Okay, I'll give an example. Elisa just said they have different. Okay, see, Fe got Fe2 plus and Fe3 plus. Correct or not? That's Fe2 plus, iron 2 and iron 3. I don't just say iron. So this is what I mean by oxidation state. The charge on the ions can be more than one. Understand? This is specially for transition metal compounds, Okay. So we'll come back to now. So this one is a definition. They won't ask you in SPM. They just ask you to calculate. Oxidation number or oxidation state is the charge on the atom of the element. Can you see the charge on it? Okay. All right. How do we determine this? What we are going to do today. All right. We're going to calculate oxidation number. Okay. Of what? I'm going to show you now. But before that, we have a few rules, You must, this one, they won't give you. Very simple rule. Okay, I have A, B, C, D, and E. Only five simple rules. Okay, first you see, the oxidation number of an atom in its element state is 0. What do you mean by that, If I give you sodium, all periodic table of elements, sodium, magnesium, aluminium, copper, zinc, all that, even carbon, is a non-metal but element, all elements, Okay? And inside the element, it contains atoms. You look at the periodic table, we have periodic table of elements. Inside every element, there's atoms. So the oxidation number of all of these atoms will be 0. If I just give you Na, what is the oxidation number? 0. If I give you magnesium, 0. Like that. Okay, first rule. Second rule is oxidation number of a molecule with the same type of element is also 0. Can you see? Molecule N2. Same type of element. So oxidation number is 0. O2 is 0. Cl2 0. H2 0. Sorry, this one Br2. Sorry, tambah that. Br2. Okay? Tambah that here. I forgot to put that. Br2, not Br, Br2. Typing error. Okay. Can you see that? All this is 0. Because it's molecule with the same type of atom. Again, oxidation number of an element with the same type of element is 0. Okay, Then we come to the ion. Ion, very simple. If I give you K plus, then the oxidation number is +1. It follows the charge on the ion. Is that clear? All right. Anyway, this is group 1. Okay, group 2. Ca is 2 plus, so it's +2. Al is 3 plus, +3. Br is -1, so I put -1 oxidation number. O2 minus, so it's -2. Cl is Cl minus, this is the charge on the ions, -1. This is the ion of nitrogen, 3 minus, but it's not so important. Okay? So the third rule is the charge on the ions will be the oxidation number. Okay? Then we come 2 more. After that, we start our question. Okay. Now, this is oxidation number of hydrogen in a compound. Can you see hydrogen compound? I didn't say hydrogen alone. I said hydrogen compound. Can you see oxidation number of hydrogen in a compound is always +1. Okay, what do you mean by that? Okay, here you see. This is a hydrogen compound. So the oxidation number of hydrogen is +1 always. Here also, NH3. It's a hydrogen compound. The oxidation number of hydrogen is +1. We will use this shortly in our calculation. A simple calculation. And last one is the oxidation number of oxygen in a compound is always -2. Again, compound of oxygen is H2O. So here it is -2. Here is C, this is a compound of chlorine, but the oxidation number is -2 because it's a compound containing oxygen. So we have 5 rules. Very simple, Okay, so now what we're going to do is we're going to calculate. Simple. I'm going to show you a few, then you can do it. Okay, ready? Okay, now this is nitrogen. I'm asking calculate the oxidation number of nitrogen in ammonia. I have bolded, So I want you to calculate that. So what you can do now is, maybe you can just underline this first. Okay, that is what we are calculating. Okay, so what you're calculating for N. Okay, you don't know what is N, so you put X. You're finding what is X, oxidation number, Okay, and you put a plus sign. Okay, that one's standard. Okay, now you go for hydrogen. Hydrogen just now. In a compound, the +1. The oxidation number is +1, but there's 3 hydrogen. So you put +3. Can you follow me? The plus is standard, okay? That one you just put like that. Okay, nothing here, So you put equals to 0. So this is neutral. So work out what you get. X plus 3 is 0. So oxidation number for nitrogen will be, X will be -3. When you write oxidation number, it's either positive or negative number. Very simple rule. Okay, let's try one more. Okay, oxidation number for chlorine they are asking. Okay, so I underline this. Memang the formula is like that. Okay, ready? But this time you're working on chlorine, tapi there's 2 chlorine. So what you put? You put 2x. Can you follow? Because, okay, then you put a plus sign. Okay, we go for oxygen. Oxygen is always -2. Because O2 minus, remember not? Okay, oxidation. So, but 7 here. So it's -14. -2 times 7 is -14, correct? No charge here, so put equals to 0. Can you see that? Okay, work out and see. So 2x minus 14 is 0, so x is +7. When it's positive number, you must put a plus sign there, +7. That is the oxidation, that's how we calculate. Okay, we'll do one more, number 3 now, All right, then you can try already. Okay, we are calculating oxidation number for sulfur. This is, okay, you underline there. Okay. SPM, they won't bold, they won't highlight, they'll put an underscore like that. Understand? Okay, so we are finding for sulfur, 2 of sulfur, so you put 2x. Then you put a plus sign, correct? Okay, oxygen is -2. That's 8 of oxygen, so it's -16. Okay, here you must be a bit careful, And you see they put a charge there. Here all is no charge. If they put a charge there, so you must put equals to -2. The -2 comes from here. Okay, work out now. How much you get? 4x. That is the oxidation number. So 2x minus 16 is -2. So the -16 brings the right side, becomes 2x equals to 14. So x will be what? +7. Must not put 7, must put +7, right? With a positive number. Okay, I've done the first 3. Now it's time for you to calculate. Very simple. Okay, this is the next step. Start your calculations now. The number must be either plus, if it's like 7 means +7. Or if the negative number means -3 or -2 left. Okay. Ready? Let's try it now. Okay, number 4 now. Okay, try that now. Ready? Okay, let's try that. We are working on for nitrogen. Ammonium ion, NH4 plus. So X plus, okay, hydrogen is +1, so it's +4. And that's equals to +1 there. Nothing means +1. So you work out and see oxygen number for nitrogen, where X will be -3. Okay, now you work out for number 5 now. This one, no problem. This one is rule number 2. You check and see rule number 2. It's a molecule with the same, so oxidation number is kosong, 0. This one you must work out. Okay, I underline this, underline this, underline this, this, and this. Okay, you try it now. Simple maths only, and then you just write the number below. What is the oxidation number? This one will come out in a multiple choice question. OSK. The rule, they won't give you the rule. You must you must remember the rule. Huh? Okay. Right now. This is NO2 minus, NO3 minus. Huh? Okay. Elisa, Lee, have you done B, C, D, E, and F for number 5?
Yeah.
Okay, can you give me the answer for B? And the check for number 5, B, this one?
Is it 2?
Wrong, 2 is wrong. Why is it wrong?
I don't know.
Alicia, okay, Alicia, tell me why is she wrong?
It's +2.
+2, you must put +2. You understand? Huh? Okay, you must put a +2. Well done, Alicia. Okay.
Okay.
Okay. Jain, continue C and D, Jain. What is the answer for C?
C is +4.
+4, okay. D?
+1.
+1, huh? Okay. Carry on, okay. NO2 minus. Okay, Chu, what do you got the answer for E?
For E, yeah.
This one?
3.
Cannot. I told you, you cannot put 3, you must put what? +3. Remember, oxidation number, you must put either a positive or a negative.
Yeah, +3.
+3. You put 3, they don't mark you wrong. Okay, +3. Okay, huh? All right. This one? F? Maybe
+5.
+5, huh? Yeah, that's your answer. You don't get it, huh? All right. For F will be X. We are finding for N. Plus -6. Okay, equals to -1. So -1 plus 6 is +5. That's how you calculate. Okay, carry on, huh? Do it now. Next one. Okay, this one. Okay, that's okay. G also we have, huh? G, H, and I. Okay, try that. This is nitric acid. This is nitrous acid. You know, that's also okay. I'm not bothered by name now. Okay, you work out now. This one got 3 elements. So, okay, I'll do one for you in case some of you are not sure. Okay, H is +1. Okay, always like that, huh? H is +1. Then you put plus. N unknown, you want to find N, you put +X. Okay, then you put plus here. O is -2, so it's -4. Can you see that? No charge here, so it equals to 0. Can you follow me? That's all. So X -3, so here the answer will be X is +3 oxidation state. Okay, X -3 is 0, so X is +3. Understand? Okay, try it now. This is how we calculate oxidation number. Yongsin, have you got the answer for H here, Yongsin? Have you worked out?
Haven't.
Haven't. Okay, try it now. Sandra, you got the answer for H? Sandra?
Yeah.
What's the answer for H? What's the answer? Okay, if you're not sure, now I'll show you. Huh? Okay, you underline, -2. Okay, let's check first. 2x, we are finding for N, isn't it? 2x plus, okay, this is +4. Hydrogen is +1, so +4 equals 0. So 2x is -4, x will be -2. Okay, well done, Sandra. X is -2. Okay. Yicheng, what is for I? Have you worked out for I?
+5.
+5. Well done. Good. Okay, +5. So some books they put, they write like this, nitric, SPM will just say nitric acid. Some books they put nitric, then they put Roman numeral 5 acid, Nitric 5 acid, they put like that sometimes. But SPM will just put nitric acid in, Okay, settle, Let's go next one, number 6. Okay, try number 6, okay. This time we're working on for sulfur, okay. Hydrogen and oxygen is always common number, same. The oxidation number is fixed. Edlin, are you ready, Edlin? Edlin, are you there today, Edlin?
Yeah, I doing.
Oh, doing,
Yeah.
Okay. Okay, I'm going to ask you to give me answer for A until G, Okay, the others try first. Done, ready, Edlin?
Yeah.
Okay, can you give me the first answer, A? Others, please check.
+6. The
6. If it's wrong, you tell anybody, Okay, second one?
+4.
+4, correct, sulfur dioxide gas, Third one?
I doing now.
Okay.
Yeah.
Those who are finished, just carry on, All right, the next one, okay.
The third one is 6.
6
Plus
wrong,
6.
okay. +6, yes. You put 6, they mark you wrong in SPM, Okay. Okay, correct. Go to the fourth one. This is sulfurous acid, When sulfur dioxide reacts with water, acid rain, this one. H2SO3. Okay, done. D. And then
+4.
+4. Please double check. If it's wrong, you tell the others, Okay, if nothing means, okay, good. Okay, next one, E.
+6.
+6, okay, yes. Next one. Underline for sulfur, we're working for sulfur. H is +1, remember that, okay. How much is
-2.
-2, okay, correct. Okay, last one.
Is it 0?
Cannot be 0, it cannot be 0. Right? So, wait, this is supposed to be number 7, Sorry, typing error. Okay, this 6 are removed first. Okay, we check, Am I? No problem. We check first. All right. +2. Okay, that's it. Something to +2. You see, you underline that first, isn't it? So you're working that out. So you put X, correct, You put a plus. Chlorine, you must remember, is Cl is -1. How you know? We have learned this before. The charge for chlorine is -1 because it's group 17. So Cl is always -1. So -2. -1 times 2 is -2 equals to 0. Okay. Chlorine, bromine, all, the charge is -1 because we have learned it before in your periodic table. Cl is -1. Okay, so the answer is +2. Okay, anyway, good try. Okay. All right. Try number 7, 8, 9 now, all of you. Now we're working out for chlorine. Okay. If you look at number 8, this K is +1 because the charge for K is K plus. Can you see that? K is +1 here. All right. Even like this, you see for number 9, this is Na. Na, the charge is +1, Na plus. Remember? Group 1. We are working out the chromium on it. Cr, I'm working out the Cr, I'm working out the Cr. The Na I'm not finding, I'll erase that. Na I'm not finding. But Na you have to know is +1. Follow the charge of the ion. Sandra, finish or not? Number 7? Sandra? The whole A, B, C, D, E. Have you got the answer for number 7?
Oh, yeah.
Not yet, Okay. Okay, we'll try. I'll ask Alicia Ong. Can you give me the answer for number 7? The others can check, please. A, B, C, D, E. Okay. Alicia? Number 7.
A is 0.
Number 7, A is?
0.
0, yes. Molecule is 0. Same with the same type of atom. Second one?
-1.
-1. Third one?
+1.
+1. Fourth one?
+5.
+5. Please double check. And this one, ClO4 minus. There's a negative charge there.
+7.
+7. Okay, good. Well done. Okay, try number 8 now. Just keep on trying. Remember, I told you here K is +1 because it's K plus. The charge on the ion for K. This is the ionic compound. Okay. Let me ask that. Okay. Yeah. Avril, can you try number 8, A, B, C, Avril? Give me the answer for number 8.
A is +4,
+4, correct. Okay. Second one?
+9,
No, try again. Okay, we check. K is +1, correct, isn't it? Okay, so you put +1. Because
Oh,
this is
plus 7 ah.
plus 7, yes. So you see plus x plus negative 8. Okay, equals to 0. So it must be plus 7. Your answer is plus 7.
Okay.
Okay, third one?
Plus 3.
Plus 3, Okay. Please double check, the others. Okay, we'll try number 9 now. Okay. Jaden, your turn, Jaden. Number 9A.
Number
Chromium,
9A,
this is
plus
chromium.
3,
Plus 3, Okay. Then
plus 6,
plus 6,
plus 6 again.
plus 6. So you see, one of the properties of transition metal compound, this is a transition element, chromium is they have more than one oxidation state in their compounds. This is what I mean by that. But in Form 4, you didn't understand clearly, but now you understand very clearly. Understand, Okay, you go next page. Continue. All right, try number 10. Okay, number 11. Number 10 you can do. Okay, do it first. Okay, do it quite fast. This is carbon monoxide, Sean, try Sean. 10A.
Okay. Plus 2.
Plus 2, yes. Plus 2. Second one.
Plus 4.
Plus 4. Third one.
Plus 3.
Plus 3,
Yeah.
Okay, all right. Okay, then we finish off this one. Okay, so this is selenium. All right. Okay, sorry, only one small mistake. This one I should put O3 and the 3 must come down. Okay. So now work out. Find the oxidation state of each of the following bolded element. The one I bolded. So I just put an underscore here. You're finding for this. Okay, find for this. Okay, I told you certain thing like Na, the charge is +1. I guide you, ionic compound. Right? K is also +1. Okay, try it now. Your work, this is I, iodine, you're finding for I. Okay, Na is +1. O is okay. The formula is all given. The work out for me. You can do this. That's it for oxidation number 2. It's almost 3 already, but never mind. You just finish it this one, Okay. This SB here, that is antimony, it's another element, antimony. Okay, let's check, Okay, Jain, give me the answer for A, Jain, number 11A. Jain, are you there?
Wait. Satish, what's the answer for A, Satish? Number 11A.
Plus 4.
Again?
Plus 4.
Plus 4. Yashwan, is it plus 4 also? For number 11A?
Yeah.
Okay, let's check first. Okay, this is plus 2. Hydrogen is plus 1. Plus 2 plus X. Okay, plus minus 6 is equal to 0. Okay. So, of course, 2 minus. Okay, so the answer is plus 4. Well done, Okay, carry on. Si is silicon. Can you see that? Okay, work it out. Alim, what's the answer for B, Alim? Number 11B. You can just put in the chat if you don't have the microphone. Alim, 11B. Ada jawapan? Okay, let's check first. Alim, plus 4. Is it plus 4? Please double check. For B, Satish, is it plus 4? Yes, okay, so it's plus 4. Okay, try the third one. Okay, plus 7. You can put the answer there. Okay, correct. All right. Put it smaller. You're going to put so big. Put it beside here so people can see. Okay. So plus 7. Okay. D is what? Plus 1. Okay. Then E. Okay, plus 3. We please double check. This one? Plus 5. Wrong lah. Number F is wrong. Try again. F is wrong. F padam. Plus 6. This is plus 6. You like to chunting. This plus 3. Okay. Write properly lah. Okay, plus 6. Okay, some more. Okay, this one G. I will bring it up. Okay. What is it? Plus 3. Okay. I can see, All right. It's very simple. Only certain things like potassium K is plus 1. That one you must know. You follow the charge on the. Okay. You write the answer there first, All right. I clear my drawing. All right, and then complete the others first. Okay. Okay. Again, what's the answer for H? Then put the answer there. H. H is plus 5. Okay. H is plus 5. Okay. This one. I. Plus 4, isn't it? Okay. This one. K2CrO4 plus 6. Okay. Good. Okay. Then this is plus 3 and plus 7. Okay. See, you all can get it ready. Again, here you must know K is plus 1, Na also plus 1 because it's the charge of the ion. Okay? All right, it's 3:05 today, so we'll call it a day today. Okay? Any question for today?